Assalamu alaikum everyone. This is Mohammad Fahmidul Haq, currently pursuing Masters of Social Science in the discipline of Economics at Shahjalal University of Science and Technology. Today, we'll be discussing about Stackelberg's duopoly game with quadratic costs by solving a problem set. So let's see and analyze the problem first. The problem says find the subgame perfect equilibrium of Stackelberg's duopoly game when marginal cost equals to q square for I equals to 1, 2, and market clearing price equals to a minus q for all q less than or equals to a. So now, to understand the problem, we have to first understand the Stackelberg's duopoly game. It's a game with sequential moves, meaning that there will be a leader and a follower in the game, in which the leader will make move and the follower will make moves by observing the decisions or choices made by the leader. Furthermore, we have to understand what is a subgame perfect equilibrium. A subgame perfect equilibrium means a strategy profile in which players' strategies constitute a Nash equilibrium in every subgame of the original game. The profit function for from I in the Stackelberg's duopoly game is given here. Okay, moving on to the solution of this particular problem, we are given with the cost function and the price. And we know that the total output is Q1 plus Q2, the sum of the firm 1 and firm 2's output. First, we compute the firm 2's best response to each output Q1 of firm 1. This is denoted by R2 based on Q1. R2 means firm 2's response. So firm 2's response must be to maximize their profit. So max profit of firm 2 is based on firm 1's output and firm 2's outputs, obviously, equals max Q2. This function came from the original function. Qi, in i's place, we put 2 because it is firm 2's best response, and a minus q minus q1 minus q2 came from this equation, a minus q, p equals to a minus q. We know that from here, and minus q2 square came from the c function here, the cost function, and we know that the cost function equals to qi square, and for I we're using 2 because it's for firm 2, which then yields, obviously we're gonna use the first order condition that equals to 0, and we find out that the response of firm 2 is 1/4 of a minus q1 if q1 is less than an a. In the next slide, we're gonna see about firm 1 subgame perfect equilibrium strategy. So firm 1 obviously wants to maximize their profit. So their response is denoted in generally by Ri of Qj, obviously, for firm 2's output. So that is equals to 1/4 of a minus q star j if Qj is less than or equals to a. Thus, if the quantity pair q star 1 and q star 2 is to be Nash equilibrium, the firm's quantity choices must satisfy these two equations, and these equations came from this particular equation. So you can ask me that why we used star in here. Okay, so with stars, we can say that these are the equilibrium outputs. So we have two equations and they are simultaneous equations, so we can easily solve them by the elimination method or the substitution method. So we use substitution method and find out that the q star 2 is equals to a by 5, which is the equilibrium level of output for firm 2. And from these equations, we can easily say that this is also the equilibrium output for firm 1. So a by 5 is the Nash equilibrium or the subgame perfect Nash equilibrium output for firm 1 and firm 2. Thus, we can solve this problem. There are another problem in the problem set. This is compare the equilibrium outcome with the Nash equilibrium of Carnot's game under the same assumptions. So we know that Carnot's game is a simultaneous move game. That means if player 1 makes a move at t second, player 2 is gonna make a move in at the same time. So there is no follower, there is no leader. Thus, farm 1 produces more in the sub-game perfect equilibrium of the sequential game in the Stackelberg than it does in the Nash equilibrium of Carnot's game, and farm 2 produces the less. Thank you everyone for joining me, and I wish you very good luck.